Focus because you already know what's assembly, how assembly works, and you know all the things. Always, you know this. Zain, Abdul Hussain, Umar Abubakar, Saeed, absent. Muhammad Al-Bakir, Najood, Hiba, absent. Jood, Muhammad Al-Madhuri, Fatma, Sarhan, Umar, Hamza, Kareem, absent. James, Rutuja, absent. Zainul Abidin, absent. Farah, there. Srija, there. Abdullah, there. Samira, there. Jad, Dalia, Dalia, okay. Yusuf Zain. Okay. So now you can start. So today the topic of today's lecture is the pipelining, and it will be only covered on the board. So I want you to pay attention. This is very important. Attention is very important. Okay. So now how many instructions are there? Can you see how many instructions are there? At this example, we are executing 5 instructions, and we'll see how these instructions will execute through pipelining stages through different clock cycles. Okay, and we also know. So let's assume we assume that there are unlimited, like there are 16 registers. It's not an LC3, just like a general architecture. It's a general architecture. And how many registers are there? 16. So there are 16 registers. Instead of 8 registers, how many registers do we have? 16 registers. We have 16 registers. So here we assume that we have 16 registers. Clear? Okay. And now, if you look at here, so we can divide the complete computer organization into different stages. What are these stages? Anyone help me? What are these stages? Look at the figure. This figure will be given. What are different stages of instruction execution? Yes, help me. Instruction fetch stage, then decode, then execute, then memory, and the write back. Okay, now what I'm doing, I did some color coding. So now these are 5 instructions, and every instruction has been given a different color. The first instruction I1 is blue color, I2 is black color, I3 is red color, I4 is green color. Oh, but I just use the blue color, same for I5, I1 and I5. That's just an example because I had only 4 colors. Okay. Now even if you look at here, now if you look at all the stages, the instruction fetch stage, decode stage, execution stage, memory access stage, and write back stage. And I have already divided all of these stages into different color. These elements, PC, okay, now what is PC stand for? Program counter. NPC, next program counter. IR, instruction register. Okay, all of these things are here. Look at here. Got it? Then look at the second thing. Now we have A and then what? B, I call it B1. Why I'm calling it B1, I will explain it later on. There is a reason for that. And then immediate. Now if you look at here, then in the next stage we have OP1. OP1 is here, operate 1. OP2 is here. And then we have what? ALU out 1. And then I call it B2. Why B2? I will explain it later on. Then we have the memory stage. When you look at the memory stage, we have ALU out 2. I will explain what ALU out 2 is. And then MAR, MBR, and LMD. LMD stands for what? Load memory data. And then we have MUX, and then we have write back stage. So these are 5 stages. Got it or not got it? Any question? Okay. Now when you are starting this program, what is the initial value of the program counter? Can you tell me what's the initial value of the program counter? Let's say we start with clock cycle 1. So now I'm starting with clock cycle 1. So now basically here, what I'm going to do, so I'm now starting with clock cycle 1. And then this is my clock cycle 1. This is my clock cycle 1. This is clock cycle 1. This is my clock cycle 1. What is the initial value of program counter? Help me. 300. So the program counter is 0x3000. And this 0 is 300. It means that there is some memory, and this memory store the instruction. Which instruction is storing in memory? At this location. Help me. Instruction 1. So instruction 1, this is an add instruction. It means that add instruction is now stored in its binary format, which is pointed by PC. Got it or not? So now we have the program counter is pointing here. So what is the value of PC? 300. So the value of PC is 0x300 in clock cycle 1. Am I right or not? And what is NPC? NPC is actually the next program counter. And if it's an LC3, and LC3 is a word addressable architecture, so the NPC will be actually just meaning in increment 1. So what will be NPC here? Help me. 3001. You got it or not got it? Okay. Now 03001, and then we have an IR, instruction register. Okay. So who is pointing to the instruction? Who is pointing to the instruction? PC. Okay. It will go where? Remember, it will go to MAR. And from MAR, it will go where? MBR. And from MBR, where it will go? Help me, the instruction. IR. So it means now we are fetching the instruction. We are fetching the instruction. And since we are fetching the instruction, so it means that what will IR contain? IR will contain in clock cycle 1, will contain the machine code of I1 in its binary format. This is clock cycle what? 1. So now, initially, we are in the fetch stage of instruction 1, which is in blue color. Okay, now when we have the clock cycle 1, this instruction will proceed to the decode stage in which clock cycle? Help me. So this will go, okay, so basically this instruction 1, so please remember, so now we have different things. So I need your attention, please remember, if you want to do good in your quiz 3, I need your attention here. Okay, so now we have in clock cycle 1, So we have I1, I1 is in which stage? Instruction stage. In clock cycle 2, I1 will be in which stage? Help me. Decode stage. I1 will be in decode stage. So it means that now this instruction proceeds to the decode stage in clock cycle 2. In clock cycle 2, okay, now what we are going to do? So in clock cycle 2, what will be the value of A? A is actually the first operand. Okay, now if you look at this instruction, what will go to A? Help me here. R0. What is the content of R0? So can you see here in clock cycle 2, so basically A, the value of A, now I'm using the black color for the decode stage. So now in the decode stage, can you see here in the decode stage? So can you see here in the decode stage? So A, so we have now moved into the clock cycle 2. When we move to the clock cycle 2, and now I'm using the same because I'm using the blue color for the decode stage. So this instruction moved to the decode stage. The value of A will be R0. And if you look at the value of R0, the content of R0, what is the now the content of R0? Help me. 2. Clear or not clear? Okay, now this will go to A. This will go where? B. What is the content of R1? 3. So R1, which value is now 3, will go to the B register. Any question? Clear? In the decode state. Okay, now the immediate field. Is there any immediate field? No. What should be the immediate field value? Don't care. You don't care because you don't care. The same thing, the poor professor. When I'm teaching, some people are busy in their mobile and some people are busy in their laptop, so you don't hear me. You ignore me. So basically you ignore immediate similarly as you ignore me during the class. Got it or not got it? Any question? Any question? Okay, this is now clock cycle 2. So in clock cycle 2, instruction 1 is in decode stage. What about in clock cycle 3? Help me. Yes. Instruction will move to which stage? Execute stage. When instruction will move to execute stage, okay, now we have op1 and op2. So this R0, because this is now R0, so the content of R0 is now in A register, the content of R1 is now in B register, so this A will go where? To the ALU. Op1, so op1, now in clock cycle 3, now we are in the clock cycle 3. And this instruction moved to the Which stage? To the execute stage. So operand 1 will be the same thing as what? R0. And what will be this value? Help me. 2. So basically this will be actually, it will be 2. Clear? And it's the same thing as previously A, because op1 will be the same thing as A, which is actually 2 from the previous cycle. And what will be the value of op2? Help me. 3. So it will be the same thing as B1. Clear or not clear? Any question? Now we have A and B. We have the 2 operands. We have not the 2 operands. Okay, but the thing is, now what operation is this? Add. We need to add them. If we add 2 plus 3, what's the result? 5. What value will go to LU out 1? 5. So basically, this result is now 5. And what is actually 5? 5 is actually op1 operation, not operation can anything. Op1 operation, op2. It can be add, it can be add, it can be any other arithmetic or logical instruction. It can be any, but this is just as an example. If I change the value, all the table content will be different. If I change the value of R0, R1, in the example I will give you this table. And this will be the question in your quiz 3. I am telling you this is your question in your quiz 3. We will do 2 or 3 examples. 2 or 3 examples. And other example I will give you, and then you will solve it by yourself, and then I will come to you if you need any help, you can ask me. Any question? Okay, now B2. Please remember, in the execution state, B2 is the same thing as B1. What is the old value of B1 now? 3. So B2 is the same thing as 3. And why I am doing that, I will explain it later on. Okay, but this B2, please remember, this B2 is now used in STR instruction. So basically we can also put it don't care. Either it can be 3 or don't care. I'll explain it later on why. Any question? Clear? Okay. Now this instruction I1 will move to which stage? In the next clock cycle. What will be in clock cycle 4? Yes? Yes? So basically it will move to which stage? Memory stage. So this I1 will move to the memory stage in clock cycle 4. So now this is my clock cycle 4. And if you move to the ALU stage, ALU out 1. ALU out 1 will have the same value as ALU out 2, it will have the same value as ALU out 1. What is the value of ALU out 1 in the previous cycle? 5. What will be the value of ALU out 2? 5. Are we accessing the memory? No. What will be MAR? Don't care. What will be MBR? Don't care. What will be the value of LMD? Don't care. LMD is load memory data. Okay. Clear or not clear? Now this instruction I1 will move to which stage in clock cycle 5? Help me. Yes, Jude. Jude, I need yes. I know that you are ignoring me. Don't care. I don't care for you. Yes, I know that. Okay. So now in clock cycle 5, what will happen? Yes. What will happen in clock cycle 5? 5. Yeah. Yes, Dahlia. What will happen in clock cycle 5? Yes. Restart. No. Instruction 1. This is instruction 1. There are 5 stages. First, it will move to fetch stage. Then you decode, then execute in memory, and then help. So in clock cycle 5, clear? Instruction I1, I will ask a question from you too again. So please be attentive. So in clock cycle 5, so now we are in clock cycle 5. And this instruction will move to the write back stage. Okay, now if you look at the write back stage, okay, what we are doing? We are adding the content of R0 and R1 and store it which register? R3. So R3 will be written in which clock cycle? 5. So basically, now can you see right value of, we are writing R5 in clock cycle 5, right value. And what is the right value? The right value is the same thing as value of 2. Which value? Because what we are doing? We are adding what? 2 and 3. What's the result? 5. And 5 will be stored in which register? R1, R3. So what's the value? Right value? Help me. Okay, now I'm using the blue color. So this is actually 5. 5, don't care, and don't care. And the right value is 5 in the next clock cycle. So in clock cycle 5, it is 5. And what is the right number? Which register we are writing? R3. Okay, what is the value of R3, initial value of R3? 2000. So it means that the new value of R3, yes, what will be the new value of R3? Help me. Yes, Jude. What will be the new value of R3? The new value of R3 will be 5. And in which clock cycle it will be updated? In which clock cycle it is updated? Help me. Yes, it will be updated in clock cycle. Any question? So it means this is how the first instruction will proceed through different stages of the pipelining in different clock cycles. Any question? Okay, now please remember. We didn't cover for I2. We didn't cover I2. Because now I2, if we have I2 now, I2 will be in fetch stage in which clock cycle? Clock cycle 1 or clock cycle 2? Clock cycle 2. So it will be in fetch stage. And in decode stage, yes, Jude. Yes, I2 is now in instruction fetch stage in clock cycle 2. In clock cycle 3, which stage? There are stages. Fetch, after fetch, which stage? Instruction fetch, then decode. If you have some problem with the I, you can sit here, no problem. Yes, please come, because if we have, you can see. Okay, now can you, Dalia, can you help me? In class cycle 3, in which stage? Please sit here.
I have a picture from the book.
No, yes, please come here. Please sit here, because if you have picture from the book, you can. So now I2, this is the second instruction. It will be in instruction fetch stage in clock cycle 2, and clock cycle 3, decode stage. In clock cycle 4, execute. Clock cycle 5, memory access. Clock cycle 6, right. Clear? Okay, now what we are doing? We are now doing it for I2. Please remember now. In I2, when we reach to, okay, now please remember. Now in the next clock cycle, what is the value of PC here? 300. What is the value of NPC? 301. What will be the value of PC in the next clock cycle? Help me. 3001. What will be the value of NPC? 0x3002. And now we have the second instruction. So please remember. Now we have I2. I2, which instruction? LDR. Very good. PC was pointing here. Now PC is pointing where? To I2. So if you look at I2, what will IR now contain? Very good, Dalia. Machine code of what? Clear? Now this I2 will go to which stage? In the decode stage. In which clock cycle? Clock cycle 3. Can you see? This is a diagonal. It will move like this. It's move like this. And then this instruction will also move like this in a diagonal way and go through the pipelining stage. Okay, now if you look at here, okay, what will be the value of A now? A. Please remember, LDR R3. What will be the value of A now? R3 is now 5. Okay, now make it, please remember, R3, okay. So maybe make it R8 now. Make it R8. And R8 is actually 0x2000. Okay, now LDR, you are using LDR. Please remember, we assume that there are more registers. In LC3 there are 8 registers, but here we are assuming there are 16 registers. Okay, now R8, what is now the content of R8? 200. This 200 will go where? R8, no, this is in R8, but in the decode stage, which we are reading the registers, so it will go to register A. And can you see here in register A? So this will, please remember, this is A now, and this is now my B. So what is the value of R8 now? Help me. 000. So it means that A will be what? The content of what? The content of R4. And no, sorry, the content of R8. Yes, the content of R8. And now the content, I know I need a good pen. And what is the content of R8 now? Tell me. 0020. Got it or not got it? Okay, now we have hash 6. Are we using a second register? No. So what will be the value of B1? Don't care. Don't care, because don't care. And here we have now what? Immediate value. So basically, can you see here? The immediate value will, what will be the value of immediate value? Help me. 6. Any question? Now this instruction is now in the decode stage in clock cycle 3. It will move to which stage in clock cycle 4? Execute stage. When it moves to the execute stage, so basically, can you see here? This is clock cycle 4, so this is moved to the execute stage now. And when it moves to the execute state, here it will move to the execute state. Now we have op1. So please remember, op1 has the same thing as A. So can you see here? There is an A. Please remember, A is reading from the register file. A. What will be the value of op1 here? Huh? 0x, it is the same thing as A. So this will be have 0x2000. So this thing will move the same thing. What will be the value of op2? Please remember, this is my op1. Here it's op1. Op1 is coming from A or it is coming from NPC. But now we have an op2. Since we have an op2, it's coming from what? From B or either from what? The immediate. And since we have now in this case B is ignored, when B is ignored, which value will come here? 6. The immediate value. So what is the immediate value here? 6. And 6 will go where? 6. So this is the immediate. So basically, if this is in, okay, if this is in, please remember now this is a general, now we are generalizing it. If it is an R-type instruction, RS2 will go to op2. And if it is an I-type instruction, then
Immediate.
what will go to B? Yes? The sign extension of the immediate field. Not its immediate. The sign, because the immediate field is typically smaller. Clear or not? Okay, now we have immediate 6. Now please remember, now we are in A layout 1. So this is my register A, so it's 2000. This is my op2. Which instruction is this? LDR. If this is an LDR, we need to compute the effective address. And how an effective address is computed? Anyone may help. Anyone, please. Yes, Samira. How we can compute the effective address? No, for LDR.
Oh, the value of R8 plus.
Yes, the value of the base register in general. So the value of the base register, which in this particular example is R8, and the sign extension of the offset, which is actually R6. So basically, what we are going to do, so we are going to have an op1 and the sign extension of the offset, which is actually Z, where it will go? A layout 1. And if you add them, what is the result now? 0x2006. And I'll explain this in an example. Okay, so now in this example, R8 is pointing here. R8 is pointing to 0x2000. When R8 is pointing to 2000, R8 is pointing to 2000. What is the offset here now? 6. What is the effective address? 2006. And if it's 2006, what is its content? 91. Clear? Okay. Now this 2006 will go to MAR or MBR? Help me. MAR. And where 912C will go? Clear? Any question? So now if you look at here, so now this is an LDR instruction. This is an LDR instruction in which we are fetching the data from the main memory, whose effective address is calculated by adding the content of the base register, which in this example is R8, and the sign extension of the offset, which in this particular example is 6, and we compute the effective address. So this is actually 2006 is now the effective address. When this 2006 is now the effective address, okay, now in this case B2, so B2 basically we will ignore B2. This is don't care now, because B2 is only considered for STR instruction. I'll explain it later. Clear or not clear? Okay, now this instruction will move to which stage? The memory stage in which clock cycle? In clock cycle 5. So this will move to the memory stage. Okay, please remember now. Now this is area out 1. This is area out 1. This is area out. This will go to MAR. So this is go to MAR. So this is area out 1. It will go to MAR. What is the value of MAR? Help me. 2006. Clear? Okay. Now this is go to MAR, which is 2006. What will be the value of MBR in this example? 912C. Very good. Because this is actually, can you see here? This is now the effective address. And the effective address is calculated by R8 plus 6. And this, whatever this value will go to MBR in the memory stage. And this value will go to MAR in the memory stage. Any question? Yes?
Professor, for the second instruction, the opcode we put for A0x2000. This is the address or the content?
Which one?
Opcode 1.
Operand 1, not operand 1. It is operand 1.
So it's the address or it's the content?
It's the content of the register.
So the content and the address of the...
Yes, it is actually this. I will explain it. This operand 1. So this is operand 1. I call this. It's not operand. It is operand 1, not operand. Operand 2. Operand 1 will be the content of the base register, and that is the content of the base register R8, and this is the content of the base register.
And the address of R8 is 200 at the same time.
Why you are confusing with the address of R8? The problem is that if you look at, listen, if you are saying that there are 4 bits, so this will be 00000001 and blah blah blah, and the address of R8 will be 1000 in binary. You got it? You are confusing yourself with the register. Does not have any. The registered index is actually the address. You got it or not got it? Now I'm talking about the content of R8, not the address of R8, which is actually the index of 8. You got it? I hope I answered the question. Good. Okay, now what we are going to do, okay, what will be now in MBR? Okay, now please remember, this will go to MAR, this will go to what? MBR for load instruction. And from MBR, where it will go? It will go to LMD. And what will be the value of LMD here now? 9126. Any question? Any question? Okay, now this instruction I2 will move in clock cycle 6 in which stage? Right back stage. So in clock cycle 6, this instruction will move to right back stage. All the markers are, I don't know, very bad, I don't know. Yes, this is good. In clock cycle 6. Now we are in the clock cycle 6. And in clock cycle 6, okay, now please remember, in clock cycle 6, okay, area out 2, area 2 will be ignored here, doesn't matter. And then we have, okay, now in clock cycle 6, which value? This value will go where? In which register? R4. And this is R4. So basically, what will be the right value? Right value? 9126. Very good. And what will be the right number? R4. We are writing R3 in clock cycle 5. We are writing R4 in clock cycle 6. So this is R4. So it means that R4 will be overwritten. R4 will be overwritten. And what is now the content? 912C. In which clock cycle? Any question? Any question? Now, what? Now please remember. Now we should proceed to which instruction? I3. Which color? Red color. Okay, please remember, this goes in diagonal. So this is just like goes in diagonal. This also goes into diagonal. What will be the value of PC here now? Help me. 2. I need to fetch a good marker. Okay, now In the next class cycle, what is the value of program counter? Help me, please. NBC, IR, the value of A,
R1.
R1. What is the content of R1? 3. Clear? The same thing. The content of R1. So this is the content of R1, which is actually 3. What will be the value of B1? Don't care. Because you are not accessing them. What will be the value of immediate 6? 4. It will go to the immediate, the next stage, the execute stage. Yes. What will be the value of operand 1? A, which is actually 3. What will be the value of operand 2? Immediate. So this is immediate, which is what? 4. And what we are going to do? Add. And we add both of them. R1 plus 4. 7. What will be the value of B2? Don't care, because you know it's don't care. Okay, now we move to the LU out 2. LU out 2 will be the same thing as LU out 1. What is the value of LU out 2? Help me. 7. And all other fields will be don't care, because this is not a load or store instruction. And then if you look at here, this LU out 2 will go to which value register? 7. And which register will be written? R5. So it means that R5 will be written in which clock cycle? 7. So R5 will be written, and the new value will be what? Help me. And please remember, this will be the question. This will be the question in your quiz 3. So I'm telling you, I will do more examples. I will do more and more examples. So basically, then you should be prepared for your quiz 3. Okay, I will give you a maybe in the next class I will bring a paper and then you will try to solve it on your own. And then I'll help you out. I will help you out there. Okay, now in this case, now we have an I3. I3, in which clock cycle it is in first stage? Help me.
4.
Then instruction decode, instruction execute, instruction memory, and then what? Now we are finished with how many instructions? 3. Okay. Okay. Now we are going to the next instruction. And which color I'm using? Which color should I use? Green. So meaning I will be using the green color. So this is so simple. What will be the PC? Help me. 0 is 3, 0 what? 3. Then NBC 3004. Very good. Machine code of what? I4. What is the value of A? No, this is now a little tricky. Why this is tricky? This basically, whenever you do, please remember, this is very important. The LDR. If you look at what is the difference between LDR and LD, please look at the black and the green color. Okay, please remember, this is very important. Now if you are working, and why? Because I want to do a comparative analysis. Let's assume we have an LDR here. Now let's assume we have an LDR. I don't have any space here. Maybe I will do it here. So what is the first instruction? LDR, R4, R8, H8. Okay, this will go to what? Operand 1. This will go to what? Operand 2. Got it? When we add operand 1 and operand 2, so if we add, so what will be the effective address? Operand 1 plus what? Any question? Operand 1 plus operand 2. And this will be the effective address. Okay. Now look for now please remember, this is tricky. How do we calculate the effective address? So this is the effective address. So this is actually what? Actually this is our base. And what is this? Awesome. Now look at the LD instruction. Please remember, if we have an LD instruction and then we have R6 #5. How do we calculate the effective address here? Anyone may help. Anyone? Very good. So effective address can be calculated by what? NPC plus what? offset. But now the problem is this. This is the problem. This is the problem here. A will always come from here, and where NPC will come from here. So we need two NPC, NPC 1 and NPC 2. So this is my NPC 1. This is my NPC 1. And please remember, now what I'm going to do. Please remember, this NPC will be only relevant. This NPC will be only relevant for PC relative addresses. And what is PC relative addresses? LD and ST. No, LDR is not PC relative. No, LDI is a different thing. LDI is a different thing. But don't confuse it with LDI, just plus. So now we have, please remember, now we have an NPC 1 here. But now what I'm going to do, I'm now going to add another, this is NPC 1, I'm now going to add another thing which is called as NPC 2. It's not there, but I'm going to here, NPC 2. And NPC 2 will be ignored here. NPC 2 will be ignored here, but NPC 2 will be ignored here. So this is actually, there will be ignored here. And why I'm doing that, I'll explain it. No problem, I'll explain each and everything. Okay, please remember, now we have an LD instruction, LD R6A. Do we require an A here? No, there is no A here. So what will be A here? In clock cycle 4, help me.
Okay.
Don't care. Because in computing the effective address, we do not require the first operand A. We require NPC. Okay, now, what will be the value of B1 here? Don't care. What will be the value of immediate 6? 5. And what will be the value of NPC 2? Because if we have B1, then we have B2. NPC 2 is the same thing as NPC 1. And what is the value of NPC 1 in the previous clock cycle? 3004. Got it or not got it? Okay, now we move to clock cycle 6. Now this instruction is in the first stage. Then it moves to which stage? Decode. Then it moves to which stage? Executes. Okay, now this is important. Now we have operand 1. In operand 1, we need, in operand 1, please remember, this is a path. Please remember here, this is NPC. Here, at this stage, this is a pipeline register. Here it is NPC 1, and here it is what? NPC 2. Okay, now here, if we have B1 here, at this line we have B2. Okay, now we have LU out 1 here, at this point of time. We have, at this point of time, what we have to do? L2. Why we are doing it? Because the LU out 1 will be overwritten by the next instruction. That's the reason. Because if you look at here, if we have this LU out 1 here, now can you see here? Now we have LU out 1 here, 5. And this 5 needs to be overwritten here. But now the problem is this. This LU out 1 is now written by the next instruction. So to avoid overwriting the old value, we need a temporary register. Got it or not got it? Okay? Okay, now what we are going to do? So, okay, what should we do now? Yeah. Now we move to which stage now here? Execute stage. If we move to the execute stage here, what will be the value of 1? NPC2. And what is the NPC2? So the up 1 is NPC2. And what is the value of NPC2 here in the previous cycle? 3004. We cannot use NPC because NPC will be overwritten, which is actually 3005, which will be incorrect. Because can you see here? Now please remember here, if you look at here from the general perspective, this instruction has an address of 3000, 3001, 3002 and 3003. And if you want to calculate the target is actually incremented PC, which is 3004 plus the offset. And for that, 3004 is relevant, not 3005. Got it or not got it? Okay, now if you look at here, now NPC2, which is actually 3004, what will go to operand 2? The sign extension of the offset, so which is actually 5. Any question? Okay, in my next, when I will rub this off, I will tell you now all the generalized concepts. I will generalize the concept later on. Okay, ALU out 1. What will be ALU out 1? We need to calculate the effective address. 3004 plus 5. 3009. B2 is ignored. Okay, now we move to LU out 2 stage. Okay, what is now LUO2? Please remember, this is an LD instruction. We are loading from the main memory. So basically, now this is actually 3004. 3004 is where? NBC 2. This 4 is where? Immediate value. And from immediate value, it go to NBC 2, and then it's the immediate value, we add it. What is the factory address? 3009. So 3009 will be your MAR. 3009 will be MMR. What will be in MBR? FBF2 will be in MBR. And this ABF2 will also be in what? LMD, load memory data. You got it? And then it will be load memory data, and this ABF2 will go to which register? R6. So what big value is R6? No, what is the value, sorry? AB and R6. And this R6 will be overwritten in which clock cycle? Clock cycle. Can I explain all of the stuff on the lecture slides? No. So that's the reason. So for applying all the questions, I will solve it on the board. Yes?
So this is the empty or is before?
Which one?
Here. Like you said before the diagonal.
No. So this is fetch stage, decode stage, execute stage, memory stage, and write back stage.
No, here this one.
Which one?
These boxes, they stay empty.
Which boxes?
Like clock cycle 1 for the decode. Execute.
Yeah. So basically, okay, now please remember, since this is the first instruction, so for that we need another result I0.
Oh, okay.
So for that, can you see here from here, all these things. So all these things will be what? Don't care. All these things what? Don't care. All these what? Very good. Now you are asking question. Very good. But now this will be filled. This will be filled for the next instruction, by the next instruction as we move on. Any question? Any question?
And the quiz will leave them empty or we write don't care?
You can say okay, anything that's empty will be assumed as don't care. But if you don't have anything, you can say you can write any empty thing will be considered with a don't care. Clear or not clear? Any question? Should I proceed? In the exam, I will give you this figure, and this is actually the content of quiz 3. Up to you, your choice. Yes.
For instruction 1, shouldn't B2 be the same as B1?
Which one?
For the first instruction.
For the first instruction, in which clock cycle?
B2 is clock cycle 3. Shouldn't it be the same as B1?
No, but the thing is, B1 and B2 is only used for the store instruction. For all other instructions, you should don't care. Got it? So B1 and B2, I will explain it because I didn't cover with STRs. Right? Now I will cover STR, then you will understand why I'm using B1 and B2.
What about NPC2 and NPC1? That's only used for LD?
Yes, no, please remember, NPC1 and NPC, that's a very good question. NPC1 and NPC2 is only used for the LD and ST instruction.
Okay.
So please remember, NPC1 and NPC2 will be used only for LD and ST instruction, which is PC related instruction.
And B2 and B1 is only
B1 and B2 will be only used for the store instruction. It can be either STR instruction or SD instruction. Got it or not? So B1 and B2 will be used for which instruction? Store instruction. And I'm going to do that. Any question? Okay. So even if it is if it is what? ST. And now after that, when I will rub everything off, I will now generalize the problem. How it will work. Got it or not? Any question? Should I proceed? Okay. Now I'm moving to instruction number 5. And please remember, in LC3 there is not only one instruction, there are many instructions. You need to look into the table. And at home, when you go home, you can try for all instructions. It's not only these instructions. Okay, now instruction number 5. If you look at here for instruction number 5. For instruction number 5, this is the store instruction. What will be the value of PC? Help me. Clock cycle 5. P00 what? 4. NPC?
3005.
IR? Okay? Now, we have A and B. What will be the value of A? Content of R8. What is the content of R8? 2000. What is the content of B1? Now B1 is important. Please remember, this is very important. So this, we have an STR instruction. Please remember, for STR instruction, this is tricky. This is very